Hello, and welcome to this film, which is all about mass-to-mass stoichiometry, or in other words, mole calculations that basically involve mass of substances. Now, hopefully by the end of this film, you'll have actually put together quite a few of the different things you've been learning in the previous films. So you'll combine your knowledge of mass-to-mole conversions and use your knowledge of mole ratios from balanced equations to carry out calculations that basically involve different masses of substances that are reacting or being produced in chemical reactions. Okay, and hopefully you'll also understand the difference between a theoretical and a percentage yield, and you'll be able to calculate both of those. Now, you might, every time you do one of these calculations, figure out what it is you're supposed to do. But some people like to have a recipe that they can kind of follow every time they do one, which is a little bit dangerous because it means you're looking out for particular types of questions rather than trying to, be good at answering unfamiliar questions. But anyway, if you are someone who likes to have a recipe, these are some general principles that you might try and follow every time you do a mass-to-mass calculation. You'll first of all be converting the mass of one substance into moles, okay, using formulas that you've used. You'll then use the mole ratio from the equation, which we talked about in the last film, to find the moles of another substance, whether that's a reactant or a product, or whatever. And then once you've done that and you've found the number of moles of the other substance, you'll convert that back into a mass. Okay, so bearing that in mind, let's do an example. What mass of calcium carbonate needs to be heated to produce 112 grams of calcium oxide? Now, there's lots of things in this equation, but really and truly, we're only interested in the two that we're being asked about and the one that we're being told about, okay? Or rather, I should say, the two that we're being asked about and told about, okay? Now, we're told that we're producing 112 grams of calcium oxide, okay? And we're being asked what mass of calcium carbonate do I need to heat to produce it. So they're the two substances that I'm interested in. Okay, I'm being asked to find the mass of that. Oops, let me just do that in white because it shows up better. The mass equal. Okay, so I'm being asked to find the mass of calcium carbonate here. Now, the mass of something is equal to the number of moles times the molar mass. But I don't know the number of moles of calcium carbonate. I could figure out its molar mass from the periodic table, and what I should also be able to do is relate the number of moles of it to the number of moles of calcium oxide. And I can find the number of moles of calcium oxide by taking its mass and dividing it by its molar mass, right? Because number of moles is little m over big M. Okay, so 112 over 40.08 for calcium plus 16 for oxygen, so that would be 56.08. Okay, and to three significant figures, because I've been given that number of significant figures in my data, that is 2.00 moles. So my first step, if I'm following the recipe, is to go, right, what's the number of moles of the substance that I've been told about? Okay, there's 2 moles of it. Now the balanced equation tells me that there is 1 mole of calcium carbonate to every 1 mole of calcium oxide. So if I had 2 moles of calcium oxide forming, I must have had 2 moles of calcium carbonate to begin with. So the mass is going to be equal to 2.00 moles times the molar mass, which would be 40.08 plus 12.01 plus 48, and that is 100.09, which again, to 3 significant figures, because that's the lowest number of significant figures I've got in my data, that is equal to 200 grams. Okay, so there's my answer. Notice once again what I did was I converted a mass into moles. I used the balanced equation to tell me the number of moles of something else. So I said the number of moles of calcium carbonate was the same as the number of moles of calcium oxide. In other words, the number of moles of calcium carbonate was 2 moles, and I multiplied that by the molar mass of calcium carbonate to find its mass. Okay, just do another example. How much aluminium oxide will form when 250 milligrams of aluminium is oxidized. Okay, now this time we're being asked about the aluminium oxide, which is here, and the aluminium, which is here. And I'm being told that there are 250 milligrams of this, so I need to just turn that into grams if it's going to be easy to deal with. 0.250 grams of aluminium. Okay, now once again I'm being asked how much aluminium oxide will form, so the mass is equal to the number of moles times the molar mass, but I don't know the number of moles even though I can find them. So let's first of all find the number of moles of aluminium, and that will be 0.250 divided by the molar mass of aluminium, 26.92. That's right. And that is equal to 9.29 times 10 to the minus 3 moles. So I've found the number of moles of aluminium. I'm now going to relate that to the other substance in the balanced equation that I'm interested in the question. I'm just going to write an algebraic expression like the ones I was talking about in the last film and say that the number of moles of aluminium oxide, that's the one I want to know, is equal to 2/4 of the number of moles of aluminium, or in other words, it's half that number. So half of this is 4.64 times 10 to the minus 3 moles. Right, and now I know the number of moles of aluminium oxide, so I can multiply it by its molar mass. And the mass is equal to 4.64 times 10 to the minus 3 moles multiplied by the sum of all these atomic masses, so 2 times 26.92 plus 3 times 16. And if I plug that number into my calculator, I find that it's 0.473 grams. And I'm giving it to 3 significant figures because that's what I was given in my data. I might choose to give that in milligrams, in which case I'd write 470 milligrams. Okay? So there we are. 473 milligrams could form from 250 milligrams of aluminium. Now this leads me on to talking about the difference between a theoretical and a percentage yield. So bearing in mind that we've just calculated how much aluminium oxide will form when 250 milligrams of aluminium is oxidized, we decided that would be 473 milligrams. This is what is called our theoretical yield. This is how much I would form if I had that amount of aluminium and enough oxygen to react with all of it, and I was 100% successful in turning all my reactants into products. Okay, so in other words, the theoretical yield is the most that I could possibly make from my starting materials, based on the mole ratio and the amount of them that I start with. The percentage yield, however, is how much I actually make, expressed as a percentage of my theoretical yield. So in other words, my theoretical yield is going to be the actual yield, my percentage yield is always going to be the actual yield divided by the theoretical yield, which I'm just going to shorten to the yield, okay, theoretical yield multiplied by 100%. Okay, so in this case, I've actually made 300 milligrams. Dividing that by 473, I don't have to put the units in because they cancel out, times 100%. And again, I've got 3 significant figures, so I'm going to give my answer to 3 significant figures, and that equals 63.4%, the 3 significant figures. Okay, so hopefully that's clear about what the difference between theoretical and percentage yield is and how to find them. And what's more, hopefully you understand how to do a mass-to-mass calculation now. It is absolutely key that you practice these kind of calculations, because if you don't, you rapidly forget how they work, and even if you think they're quite easy now, without practice, a few weeks on, they can seem very difficult indeed. So check that you understand what you've done in this film, check that your notes make sense. If there's anything you'd like to ask about, please come and find me as soon as you can so that this doesn't become a problem for you, or post a comment on YouTube so that other people can see the questions that you've asked.